This guide will teach you how to make height map images for city skylines too, from real-world map data. It will not teach you how to use the map editor in city skylines too, except for a few things. With the right source material, you can take full advantage of the map editor's resolution. Tools you will need. QGIS, a geographic information system. Access to map data, in the form of GeoTIFF files, DEM files or the like. These are usually free to download, from local government sites, universities, and NASA. An image editor, like Adobe Photoshop, GIMP, PaintShop Pro or similar. Our goal: to export a height map from a software that can handle real-world map data. City Skylines 2 requires two height maps of 4096 by 4096 pixels grayscale image, with colors from black to white. Dark colors are low elevation, bright colors are the highest points. The minimum height in City Skylines 2 is 0 meters and the highest can be defined in the game. The standard is 4096 meters. A map of a coastal area will have an elevation of 0 to x meters, depending on the terrain. Water level will be at 0 meters, no matter the real water depth, as these maps you can download usually don't contain information about water depth. This means that our coastline cannot be at 0 meters, as we need room for the water. So, the solution is to raise the map to an arbitrary number, for example plus 30 meters. Then we have from 0 to 30 meters in the game to define the sea. If your map is at Lake Michigan, using the lake as the sea, and since the minimum elevation of Michigan State is 174 meters, there's no need to raise the overall level of the map. But we will get back to all this later. Getting started. First, you will need to download QGIS from qgis.org. QGIS comes for Windows, 64-bit, macOS, Linux, Debian/Ubuntu, Fedora, OpenSUSE and others, BSD and some tablets and mobiles. I recommend downloading the stable version. The name is something like version 3.34.5 LTR. The software is free, open source. Install the software and say yes, Windows, to install shortcuts. If you don't, you will have to manually find the installation folder, then go into the bin folder and make a shortcut to qgis-ltr-bin.exe. Setting up QGIS. This is a matter of preferences. To change language in GUI colors, go to Settings in the top of QGIS. Click Options in the drop-down. Under the General tab, the very first selection is User Interface Translation, or the similar in your language. Change, if needed. I personally run the software in English, as it makes it easier for me to find guides online on how to use the software. A little bit further down is UI Theme. Here, you can change the software to be in dark mode, which I prefer. A restart is required for the effect to take place. You can also change things like the icon size under the General tab. Downloading the world. After installation, you will need to get a geographic map on the GUI of the program, as the GUI has no data to show you. The easiest is to use OpenStreetMap, OSM. You will need this map or similar to have a reference of the world. Newer versions of QGIS comes with OpenStreetMap access built in. Otherwise, you will have to use a plugin to use OSM. To add a map, simply go to the Browser section in the left side, expand XYZ tiles, click and drag OpenStreetMap onto your working area and release. a world map should appear. If not, try to go to Layers, right-click on OpenStreetMap in the Layer panel and select Zoom to Layers. To have some structure over your project, I recommend making a few folders for your project. For example, a folder called Iceland, a subfolder called Reykjavik, and in that folder, a folder called DM, 32-bit map extends, output, and another called water. Save your project in the Reykjavik folder. Finding an area of interest. We need the OpenStreetMap to find our ways around the global map. We can also use the map later to create an image overlay for the map editor. I suggest using OpenStreetMap, as we can do some pretty clever things when creating the image overlay. For my demonstration project, I choose Reykjavik, Iceland. As there are no rulers or guides on the size of the area we are looking at and we can't see that on the front page of QGIS anyway, we will need to set up a print page layout. A page layout is where we set the final area of our export. A print layout can be used to both print a map and, like in our case, export a map to a TIFF or PNG raster image. The map importer in Cities Skylines 2 supports TIFF and PNG grayscale, but TIFF files are preferred as they are not compressed. The files must have an exact resolution of 4096 by 4096 pixels. Downloading the first map data. Before continuing, it's a good idea to save your project. There are many ways to get Heightmap data files. The easiest way is to just use the features built into QGIS, or rather via a plugin. I demonstrated in my Cities Skylines 1 guide how you can use a feature like SRTM Downloader that uses an automation to download Heightmap data from QGIS. Unfortunately, these automated features mostly use very low-resolution source files, and that won't be good enough in Cities Skylines 2. As we have a higher resolution here to work with. But you can still use that method, if you want. After importing the map data, the workflow is the same. Your best choice is to see whether your government offers some kind of download site for map data. Mine does, and I can download maps down to 1.6 meters and even 0.4 meters accuracy. Cities Skylines 2 loves high-resolution data, but be aware that large files can be hard to work on for your computer. With 0.4 meter resolution GeoTIFF files of Denmark, each file is over a gigabyte for a 10 by 10 kilometers tile. That may not sound like much, but you often have to load 4 to 6 files to get the data for your area of interest. Working on such large files will slow your PC down. A great resource for elevation Heightmap sites is the Discord server, Cities Skylines Modding. Under Maps Resources, there's a subforum called Link Depot, Free Heightmap Data. If you are using low-resolution maps, SRTM etc., you could add some blur in Photoshop, like adding 0.5 radius Gaussian blur, but it will never be as good as a higher-resolution Heightmap file. Let's try using this web link. Link is in the description. We will download an area over Iceland. We only want to download one local file, as we don't know yet how many files we will need. If we compare the OpenStreetMap with the map on the download page, we can see that it is here Reykjavik lies. So let's click that square and download the file. I don't speak Icelandic, but doing it translate of
Hæðarlíkan í SN 2016
in Google Translate tells me that this means elevation model ISN 2016. So, this is most likely DEM files from 2016. Hovering over the link in the download, we can see it says DEM and that it's a TIFF file. So, we are most likely good. Save the downloaded GeoTIFF file in the DEM folder of your project. Now drag it into your project in QGIS. If nothing happens, right-click the DEM layer and choose Zoom to Layers. The grayscale DEM file should cover Reykjavik on the map. Right-click the file and choose Properties. Click on Information. Scroll down the text to find Coordinate Reference System, CRS. Under Name, it says EPSG 8088 ISN 2016/Lambert 2016. Remember this or write it down. Setting the Project Reference System, CRS. Since the Earth isn't flat, we need to change the CRS of the desired area. In the very bottom left, there is a text that says something like EPSG 32219 or similar. Click that text. A window for Project Properties CRS will appear. Here you will need to find the right, most suitable map translation of the location of interest. You can use the Coordinate Reference System CRS you just got from your newly downloaded file, or choose your own. There are often several projections that suits an area. None of them are right and none of them are wrong. It's just not possible to project a cutout from a sphere onto a flat plane perfectly. That's why CRS projection exists. In theory, if you choose a different CRS than what the file is made for, the file should be reprojected, but we won't do that. It's outside the scope of this guide. If you want to use the projection of your downloaded file, simply do a search. In my case, I can just search for 8088 from my EPSG 8088 ISN 2016/Lambert 2016 projection in my file. Also, it's the projection set by the official Landmælingar Iceland. Right now, my DEM file is tilted, but as soon as I choose and apply EPSG 8088 ISN 2016/Lambert 2016 to my project, the map looks fine. If you want to use another projection than what your file says, click the top one once and use your key down to select each choice and look carefully on the map below. You will want to find a pink area that covers your area of interest. For example, for New York, the best choice would be WGS 72/UTM Zone 18N-EPSG 33218. Just a warning. There are hundreds, if not thousands of projections in the list. A good place to look is under Universal Transverse Mercator, UTM, or Transverse Mercator. In some cases, you can be unlucky that your files have an unknown projection. In that case, you have to do a reprojection. If you still have the DEM map visible, covering the area of Reykjavik, disable it by clicking the eye icon next to, in my case, Islands DEM v1.0_2x2m_massal_ASN2016_57 in the Layers viewer. Now, you should only see the OSM map. Setting up a print layout and adding the map layer. This section assumes you are using the default scaling of 4096 meters in the map editor. After settling on the area of interest by zooming to that location, click Project in the top menu, choose New Print Layout, and give the layout a name, e.g. City Skylines to Reykjavik, Iceland. After clicking OK, the Print Manager will open with a blank sheet. If you close the Print Manager, you can always get back to your created layout by clicking Project. Then hover your mouse over layouts and your layout, in my case Cities Skylines 2 Reykjavik, Iceland, will be visible in a dropout. Click the preferred layout to open and the Layout Manager will reopen your layout. You will see a blank page and, in my case, due to my geographic location, is a blank A4 page in landscape mode. We need to change that. Click the empty page or right-click it and choose Page Properties. In your right side of the screen, you will see the properties of the layout. The tab, Item Properties, should be activated. Click the Size drop-down and choose the very bottom option that says Custom. To the right of Width and Height, there is a drop-down to choose Units. Click that and choose PX. Now change the width and height to 4096. You will see the background rectangle becoming a square. Now click on the Layout tab. Scroll down to Export Settings and change the export resolution to 72 dpi. To zoom the page layout to fit your screen, click the bottom right drop-down with a number and percentage sign. Choose Fit Layout. The white page should now cover most of your screen. Now we need to add a world map to our print layout. Choose the sixth icon in the left menu, called Add Map. We now need to draw a rectangle that covers the entire map layout. Luckily, a horizontal and vertical blue, dotted line will guide us when we are right on the corners. Hold the mouse over the top left corner, where you get the dotted line, for both vertical and horizontal. Click and drag to the bottom right corner, again to get the blue, dotted lines. Release the mouse button. It will take a few seconds, but then you should see the area of your interest being painted on the map layout. If you need to refine your map on the map layout, you need to choose the fourth button in the left menu, called Move Item Content. By clicking anywhere on the map and dragging, you can pan the map. By using your scroll wheel on your mouse, you can zoom in and out. Adding guidelines to your map. Now it's time to create a grid. If you want a one-to-one accurate map in the game, these are needed. If not, you can skip this step. The grid is just to give us a sense of scale. Be sure that the map is selected in the top left to edit the properties of the map. Choose Item Properties in the menu and scroll down to the dropout, Grids. Click it. After Grids has expanded, you'll see a plus and minus button and two arrows. Click the green plus button. A new Grid 1 will be created in the field below. Select Grid 1 and click Modify Grid below. The top button, a blue arrow pointing to the left, is the close button of the grid you are currently editing. It is important to close the grid editor when you are done, or you won't be able to continue your work. The first thing we need to change is the CRS. This needs to be the same CRS as you chose your CRS under 8 setting the project reference system. On this map, it is EPSG 8088 ISN 2016/Lambert 2016. Choose the correct CRS. Interval should be set to map units. The next step is our grid size. I suggest you make your tiles so that they are the same as zones in the game, so 92 by 92 tiles of 0.623304 kilometers. The units are in meters, so replace the 0.0 in the X and Y input fields with 623.304. Your map should now have 8,464 squares of 0.623304 by 0.623304 kilometers, once we have zoomed the map to scale. The next goal is to zoom in on the map, so that we can only see exactly 92 by 92 tiles. This is to set the extent of the world map in the city's Skylines 2 map editor. We don't need to do more in the grid editor for now, so close it by clicking the blue arrow in the top. Now scroll to the top of the Item Properties tab, so that you have access to the input field, Scale. We are now going to change the scale. We are now going to be zooming and panning into the map, so that we get 92 by 92 tiles. But first, we will add some guides. Click the Guides tab. And add a guide horizontal and vertical at 1536 pixels. Also add guides at 2560 pixels. We have now made guides for the playable area. Note that these guides only work for us on the world map we are about to define. Later, when we create a map 2 for the local map, don't look at these guides. We need to add a scale bar to the map. Click the button, Add Scale Bar, that looks like a ruler. Place it in the left side and drag. Release the mouse button. Make sure the new scale bar is selected, and click the Item Properties tab. Scroll down to Display. And click Line Style. Under Width, set the value to 0. Close Symbol Settings again. Scroll to the top of Item Properties. Now, zoom in on the outmost left side of the scale bar by choosing the Zoom Z. And adjust it so that it is in line with the map's edge. To move it, use the Select/Move Item button V. Now zoom to full view by clicking the zoom level and set it to Fit Layout. Make sure the scale bar is still selected in the top right corner. Under Item Properties, go to Segments and change the Right to Right 92. This will make the scale in 92 divisions. Under Fixed Width, change to 0.623304. This makes every segment of the scale bar 0.623304 kilometers. The scale bar's left position will stay fixed, so we now need to adjust the scale of the map so that the scale stops at the right side of the page layout. Now select the map, Map 1, in the top left corner. Select the Move Item Content, C, so that we can now pan and zoom the map to the print layout. Use it to zoom in on the map so that the scale in the right side ends at the edge. As you can see, there's a time where you are either too much zoomed in or out. At that point, notice the values in the scale field. So manually write a number in the field that is in between. I'll try with 40,000. That was close. Now zoom into the map by using the Zoom Z button and drag and release to the right side of the map where the ruler is. Now, it's a bit of trial and error to get the scale right. Change the value so that the scale bar ends at exactly the edge of the map. Note that the scale bar doesn't go all the way out, so we need to zoom in more on the map, which is the same as lowering the scale number. Let's try with 39,600. Better, but do as I demonstrate here and change the value so it's perfect. Now, let's zoom out again. It's now time to pan the map so that it suits your final map. And only pan from now on. I cannot stress how important this is. We are later going to create a local map, and its position depends on the choice we make from now on. Everything we do for the rest of the project will have to be redone if you accidentally move the map later on. The same goes for our next step, panning to fit the map. When this is done, lock the map so that you can't accidentally move or zoom it. First, make sure you have the map selected in the top left. Click the Move Item Content (C) button and drag the map to your liking. If you are having trouble seeing the red dotted lines, you can uncheck the visibility of the map by clicking the eye icon. To zoom in, to get a better view, use the Zoom Z feature. If the grid is in your way, disable it. Scroll down to Grids. Click it and select your grid. Click Modify Grid. And disable it by unchecking Enable Grid. After you are done, zoom out. If you want to see how the grid conforms to your map, you first need to adjust the grid's position. This is because the grid moves when you move, pan, the map layout. Go to Grids. Enable the grid again, and now zoom in on the bottom left corner. That's because the X offset and Y offset conforms to that corner, left and bottom. Now adjust the values in the offset. Remember that each cell is 623.304 meters, so we can kind of guesstimate our values. Accuracy is not really important here. It just needs to be close enough. The only reason to have the grid and the guides is just for that. As guides. And from now on, you don't need them other than to do a final confirmation you are happy with your choice. Do a full zoom out, then zoom into the playable area. You will notice that the grid and the guides aren't on top on each other. And they should be, right? Well, the map is 92 times 92 tiles, and the playable area is a fourth, so 23 by 23. And the center half of 23 is 11.5. And half of 92 tiles is 46, an even number. So, we need to move the grid by half a cell, or 311.65 meters. So, adjust your offset by that. Zoom back to the playable area, and recheck, you are happy with your choice. Now lock the map. Close the grid editor. Scroll to the top and note the values of your map's position down. We will need them for the local map. By writing them down, you also ensure that if you accidentally move or zoom the map later, you can get back to the original position and zoom. Final thing to do is to rename the layer. Click on the Map 1 text, hit F2 on your keyboard, or double-click and give it a name. I highly recommend only doing one map per project and always start all over with a new project, unless you only want to make a new version, a new print layout, a few kilometers offset. So, we can just name the Map 1 to World Map. Adding the local map. We now need to add a new map to the Print Layout Manager. This will be the local, playable area. While the world map is technically not needed in the city's Skylines 2 map editor, the local map is mandatory. Zoom out to full view. Click the Add Map icon. Do as with the first layout, and drag and release a new map, corner to corner. Click the new Map 2. Press F2 on your keyboard, or double-click the text, and rename it to Local Map. Make sure the new map is selected. Take notice of the Xmin, Ymin, Xmax and Ymax values under Item Properties. They are obviously not the same as the ones from the world map, so change them to the numbers from the world map layout. Zoom in on a quarter of the local map, then click the eye icon a few times to disable and enable the new map, to make sure the maps are aligned. If not, check the 4 values again you just changed. If they still are a few pixels off, delete the map and try again. I have no idea why this sometimes happens. Now we need to add another scale bar. Click the Add Scale Bar button and place it on the left corner, as with the first we created. Change the E segments, right 2 to right 23. Set the fixed width to 0.623304. Zoom to the start of the scale bar and adjust its position with the Select/Move item, V. Zoom to full view. Now select the local map. Use the Move Item Content, C, to zoom the layout. Do not move the map, only zoom. Now do the same work as we just did previously. We can, however, be smart about how to position the local map. It is essentially a zoom on the center of the world map. As the zoom on the maps are linear, we can actually calculate the values for Xmin, Ymin, Xmax, and Ymax for the local map. If you have access to a spreadsheet app, like Excel, Google Sheets, or similar, use the formulas in the left image. If not, do the calculations manually via the right image. This is of course much easier than to manually do the whole zoom process, but I still recommend adding the scale bar just as confirmation. And I also recommend starting out with setting the local map to the size of the world map, then hiding the local map and showing it to see if the maps are aligned. FYI, the local map is a fourth of the world map. If you want, you can now add guides for the starting area. But since Cities Skylines 2 map editor allows a lot of customization to the starting tiles, these are really not necessary, as they change depending on where you want the starting tiles to be. But in case you want them, go to the Guides tab, add a horizontal and vertical guide at 1781 and 2315 pixels. We have now created the two maps for our project. It seems to be a long task, but really, you can do all this in about 15 minutes, by having a simple checklist. The benefit of using this method are several. You can very easily see and adjust the map by meter precision. You can also use the print layout for much more than as boundaries for the map export process we are about to do. You can do a simple, quote-unquote, export of the maps as an overlay image to be used with the image overlayer mod. You can even make several maps with water areas, forest areas, and road layouts, even as transparent images. I'll demonstrate that later. But a dedicated tutorial on this subject is coming out soon. Downloading additional map data. Close the Print Layout Manager and enable the DM file over Reykjavik. Now open the Layout Manager again by clicking Project, Layouts, and choose your layout. Deselect the local map and make sure the world map is active. In case the print layout doesn't update with the DM file, try zooming out and in with the Zoom Z. We can now see that we need additional files. 4, in total, it seems. So, let's head back to the website and download those files. Save them in the DEM folder. Now close the Print Layout Manager again, and drag the new files into your project. We need to merge the downloaded files together into one. But we have a problem. One of my layers seems to have no data. It's just a flat grayscale image. Let's try a trick. In Plugins, click Manage and Install Plugins. Click on All. And do a search on Value Tool. Install that plugin. A new panel, called Value Tool, should appear. If not, go to View, Panels, and enable it there. This tool will give us a height in meters, at the point where your cursor is. Let's zoom in on the grayscale map file, where it meets one of the other maps. By moving the mouse over a few areas, we can see that the layer actually contains height map data. So maybe we are good. Let's merge the layers. Click Raster, Miscellaneous, Merge. At Input Layers, click the three little dots. Click Select All. And then uncheck the OpenStreetMap. Click Run. This will take a while. When it's done, close the Merge window. A new file has been created, called Merged, and we can see, by zooming out, that the new file is okay. The gray area was a glitch. Double-click or right-click the merged file and choose Properties. Click on Information. Click the link next to Path. This will open the file in the Temp folder. Copy it, you can't move it, into your project's DEM folder. It's a whopper. 13.9 gigabytes in unzipped, uncompressed format. We could have chosen to use compression, but it takes substantially longer time to merge the files. But the option is in the software. I tried with high compression, and it took 10 minutes. The final file was 3.4 gigabytes. Without compression, it took 1 minute, but we end up with larger files. As TIFF files are lossless, no matter the compression, it's up to you to value time over hard disk space. Name it, your area, merged, in my case Reykjavik merged. Go back to QGIS, drag in your new file, then delete the merged file. You can now also remove the other files, the ones you downloaded from the website. From now on, we only need the merged file. Generating the two maps to prepare for export. We need two maps. The world map, and what I call the local map. To generate the world map, right-click the merged file, Reykjavik merged in my case. Choose Export, Save As. Make sure Raw Data is selected. Uncheck Create VRT and make sure the U format is GeoTIFF. Click the three little dots next to File Name. Find the folder 32-bit map extends you created earlier and give the file a name, e.g., Reykjavik World. Set the CRS to your project's CRS, in my case EPSG 8088. Click on Layout Map. Select your layout, and then choose the World Map. If you want, you can also choose a compression level here. Click OK. It will take a short while to generate the file. When it's done, you can try and hide the merged layer file. The new file should be a square. You can recheck in the Layout Manager that the area is still covered. Remember to hide the local layer then. Now do it all again and generate the local file with the same parameters. Except this time choose the local map. Click OK and let the file be generated. Check if you will in the print layout. But make sure the local map is visible and that it is on top of the world map. If for any reason anything went wrong, you can always check the values in the exporter under Extend. They should be identical to the numbers from your print layout. Evaluating and exporting the Heightmaps. First, I will rename my exports to 32-bit export local and 32-bit export world. The 32-bit part is just to remind me that these are not final files. We now need to do an evaluation of the maps. They cover an area of Reykjavik, where the sea is also present. Unfortunately, most GeoTIFF files contain no water depth information. So, the sea just has the value of 0 meters or total black. So does the coastal area, where it meets the sea. It is also black and at 0 meters. If we exported the map, as is, there would be no space for water depth. Also, there are in some cases areas inland, where the land is below sea level. The lowest land point on the globe is the Dead Sea Depression, with an elevation amounting to approximately 413 meters below sea level. So, in the Iceland project, we need to raise the whole map. But the elevation values are baked into the GeoTIFF files. We can, however, push the elevation of the whole map during export. So how much elevation is needed? Well, where I come from, Denmark, you will hardly ever see water depth near coastal areas, where the water is more than maybe 30 meters. And in Norway, I think there are fjords, with water depth of over 1,000 meters. But it's only the first 6 to 10 meters of water depth that are transparent in the game. At least in the editor. The rest of the water has the same blue color. That doesn't mean that you should just go with a water depth of 10 to 20 meters. Water volume is also a thing in the game, and you can easily drain a lake if the water level is too low. We also don't know if there maybe will be added tsunamis or something similar that can make sea water catastrophes, so it's really up to you to decide on a water depth of the sea on your map. In this case, I'll add 200 meters to the map. We need a set of command line parameters to add to our export. The standard parameters without raising or lowering the terrain is as follows. The first two values, 0 and 4096, decides the minimum to maximum height, or more precisely, that we want a map with a minimum of 0 meters and a maximum height of 4096 meters. This is a simple subtraction between the numbers. We will use these two numbers to shift the elevation. The next two is about absolute minimum and maximum height. I believe this is about the absolute maximum elevation of a GeoTIFF file, but I could be wrong. Anyways, they should not be changed. The ratio between the first two numbers can be changed. If you want a max height of 8,192 meters, the difference between the two should be 8192. Outsize tells the translator that we want a map cut to 4096 by 4096 meters in length and width. They cannot be changed. The Heightmap importer will reject any grayscale file that is not 4096 by 4096 pixels. The last parameter, R, is how the image is generated pixel by pixel, in conjunction to each other. The feature is similar to the resample option when you resize an image in Photoshop. The options are R, nearest, bilinear, cubic, cubic spline, Lanczos, average, mode. If your map has a lot of small features, like narrow canyons only meters wide, you may get a better result changing this parameter. But let's look again on the default parameters. If I want to raise the elevation of the whole map by 200 meters, it should look like this. That means our map goes from -200 to 3,896 meters. On a map from 0 to 8,192 meters, it would be. If you want to exaggerate the heights on a map, because you find it too flat, there's no reason to do it here. You simply make the map in QGIS, and after importing it to the map editor in Cities Skylines 2, you just change the height scale to whatever you want. If we check the world map by double-clicking on the file, then choose Information, we can see that the statistics_maximum is 909.371 meters, and the statistics_minimum is -8.782 meters. That's the highest and lowest elevation in my project. So, the only thing for me to consider is to shift the map up with a value higher than 9 meters to make room for water. I'll choose 200 meters, so my command line parameters would be this. We will first export the world map. Select the map you want to export, in my case, 32-bit export world. then click Raster, Conversion, Translate, Convert Format. Choose the correct CRS. At Advanced Parameters, click the Profile drop-down and choose No Compression. Cities Skylines doesn't support compressed TIFF, and I don't know about Cities Skylines 2. But the output files are so small, we won't even bother with compression. Under Additional Command Line Parameters, paste your translation parameters. At Output Data Type, choose UINT16. Under Converted, click the three little dots and select Save to File. Browse to your Output folder and give the file a name. I'll call it Reykjavik, Iceland World -200M. Now click Run. When it is done, we can click Change Parameters. Scroll to the top and select the local file. Scroll down to Converted, and in the path, simply change World to Local. Click Run. That's basically it. You can now use those two files directly in the map editor or open the files in Photoshop or your favorite image editor, if you want to change something manually, like painting the sea with a brush. Wrap up. We are done with the guide. But if you are interested, I have an addendum about creating an image overlay very quick. There are more advanced ways to make nicer overlays, but I'll save that for another video. And sorry for this fake AI voice. I only have one microphone, and it's a calibration microphone I use to calibrate audio. Besides that, I'm said to be mumbling when I talk. You don't want to listen to that. Thanks for watching. Addendum, exporting an image overlay. An image overlay is an image of a geographic map, like a Google map or as we have used in the guide, OpenStreetMap. You can then, via a mod, overlay this photo in the map editor, set an opacity on the map, and then you can see where roads go and see more precise where water edges like rivers and the sea are. It's then easier to add features with accuracy, or even use the mod to place roads accurate. The current mod for Cities Skylines 2 is Image Overlay by Algernon. It is available under Paradox Mods in the game. To export the overlay is pretty straightforward. If your OpenStreetMap is not already on top in the Layers menu, drag it so that it is the very first file. Now open your print layout. The OSM map should now be visible. If it isn't, make sure that the layer actually is on top. If it is, and the print layout still shows your height map, try zooming in and out. It can happen that the software simply won't refresh, especially if you have had the software open for many hours and made a lot of changes. So, in that case, close QGIS and reopen. Depending on what you want to do, you can either make an image overlay of the local area, or both the local and the world map. Just remember to rename the files properly. So, choose in the top left, whether you want one or the other. Also hide all scale bars and grids, or they will be baked into the image. Guides won't show. They are normally used for print layout and won't come across in the export. In the print layout, click on Layout, Export as Image, and choose the right location. The mod needs the file to be in a specific location. The location depends on the mod you are using, so check the description of the mod you want to use. Be sure to choose PNG format under file type. Give the file any name. Click Save. An image export options window appears. As you can see, the values here are from our print layout we set up in the very beginning of the video. But if we export at this resolution, the image will become a bit blurry. I recommend going with 4 times that resolution, so 4096 times 4 is equal to 16,384 pixels. This will be a heavy file, and you could go lower than that. The limit in the image overlay mod is 16,384 pixels squared. But even 4096 by 4096 would be adequate for many. Click Save. The file is now ready. You just need to install the mod, enable it, and start editing.